When people hear that NASA has found the future of mankind, and that it weighs millions of tons and is extremely far from Earth, it sounds like a science fiction movie. However, this idea is not about aliens or spaceships. It is about energy, something every human depends on every single day. Energy powers our homes, our hospitals, our factories, our transportation, and even the devices we use to read this article. As the world's population grows and climate change becomes more dangerous, humanity needs cleaner, safer, and more powerful energy sources. NASA believes that one possible answer may not be on Earth at all, but on the Moon. Right now, much of the world still relies on fossil fuels like coal, oil, and gas. These fuels are limited, meaning they will eventually run out. They also release pollution and greenhouse gases that damage the environment and contribute to climate change. Renewable energy sources like solar, wind, and hydropower are helping, but they are not always enough to meet global demand. Some countries struggle with storing renewable energy or producing it consistently. Because of this, scientists are constantly searching for new energy sources that are powerful, clean, and reliable. This search has led researchers to look beyond Earth. In space, the sun constantly releases streams of tiny particles called solar winds. These particles travel across the solar system at very high speeds. Among these particles is a rare form of helium known as helium-3. Helium-3 is different from the helium used in balloons. It is an isotope, meaning it has a slightly different atomic structure. What makes helium-3 special is that it can be used in nuclear fusion, a process that creates enormous amounts of energy without producing dangerous radioactive waste. Earth is protected by a powerful magnetic field. This magnetic field acts like a shield, blocking most solar wind particles from reaching the surface. While this protection is essential for life, it also means that helium-3 does not collect naturally on Earth. Over billions of years, almost all helium-3 brought by solar winds was pushed away. As a result, helium-3 is extremely rare and expensive on our planet. The Moon does not have a strong magnetic field like Earth. Because of this, it has been directly exposed to solar winds for billions of years. When solar wind particles hit the Moon, they become trapped in the Moon's surface soil, which scientists call regolith. Over a very long time, this process has allowed large amounts of helium-3 to accumulate just beneath the Moon's surface. Scientists estimate that the Moon may contain 1 to 3 million tons of helium-3, which is an almost unbelievable amount compared to what exists on Earth. Helium-3 is valuable because it could be used as fuel in nuclear fusion reactors. Fusion is the same process that powers the sun. Unlike nuclear fission, which is used in today's nuclear power plants, fusion does not produce long-lasting radioactive waste and has a much lower risk of catastrophic accidents. If scientists can successfully use helium-3 for fusion on Earth, it could provide clean energy for centuries. This is why some researchers say helium-3 could change the future of human civilization. The idea of mining the Moon is not new. During the Apollo missions, scientists collected moon rocks and soil and brought them back to Earth. One of the Apollo program's geologists, Harrison Schmitt, later suggested that helium-3 on the Moon could be used for energy on Earth. At the time, the technology needed to mine the Moon and use fusion energy did not exist. Today, however, science and engineering have advanced enough for this idea to be taken seriously. Mining the Moon would not look like mining on Earth. There would be no miners with shovels. Instead, robotic machines would heat the Moon's regolith to very high temperatures. When the soil is heated, helium-3 and other gases trapped inside it are released. These gases can then be collected, separated, and stored. Other useful materials, such as water, hydrogen, and carbon dioxide, could also be extracted at the same time. Helium-3 is not the only valuable resource on the Moon. Scientists have discovered water ice and permanently shadowed craters near the Moon's poles, such as the Shackleton crater. Water is extremely important because it can be used for drinking, growing food, and even making rocket fuel by splitting it into hydrogen and oxygen. These resources could support long-term human bases on the Moon and reduce the cost of space exploration. NASA has supported research into lunar resource extraction through programs like the Space Technology Research Fellowship. One researcher, Aaron Olson, studied how helium-3 could be extracted from lunar soil using advanced heating and diffusion systems. His work was connected to the Fusion Technology Institute at the University of Wisconsin-Madison. This research focuses on creating machines that could work efficiently in the Moon's harsh environment. Before any mining can happen on the moon, the technology must be tested on Earth. Scientists use special materials called lunar regolith simulants, which closely resemble moon soil. These tests help researchers understand how helium-3 behaves when heated and how efficiently it can be extracted. NASA also works with facilities like the Kennedy Space Center to test equipment under space-like conditions. One major challenge is gravity. The moon's gravity is only 1/6 of Earth's gravity. Machines that work well on Earth may behave very differently on the moon. To solve this problem, scientists plan aircraft and experimental setups that briefly simulate moon-like gravity. These tests help engineers design equipment that will function properly once it reaches the moon. Even if helium-3 mining becomes possible, nuclear fusion technology itself must continue to improve. Large international projects, like the International Thermonuclear Experimental Reactor and the National Ignition Facility, are working to make fusion energy practical. Scientists have made important progress, but fusion is still not widely available for everyday energy use. Many scientists believe that fusion energy is inevitable. It offers clean, powerful energy without the pollution of fossil fuels or the long-term waste of nuclear fission. If fusion becomes reliable and affordable, it could completely transform the global energy system. Helium-3 from the moon could play a major role in making this possible. Mining the moon would be extremely expensive and complex. Rockets, robots, energy systems, and transportation methods would all need to be developed and tested. There are also legal and ethical questions about who owns resources on the moon and how they should be shared. These challenges mean that lunar helium-3 is not a short-term solution, but a long-term possibility. This research matters because it represents hope. Humanity faces serious challenges, including climate change, energy shortages, and environmental damage. Looking to the moon for resources shows how human creativity and science can push beyond traditional limits. Even if helium-3 mining takes decades to become reality, the research itself drives innovation and inspires new generations of scientists and engineers. NASA has not solved the energy crisis yet. Instead, it has pointed toward a possible future. The moon's helium-3 will not power our homes tomorrow or next year. However, it may one day help humanity achieve clean, nearly limitless energy. The future of mankind, as NASA suggests, is not just far away in distance, but also far ahead in time. What once sounded like science fiction is slowly becoming scientific research. The idea that energy for Earth could come from the moon shows how interconnected space exploration and everyday human life truly are. While many obstacles remain, the work being done today lays the foundation for a cleaner, safer, and more sustainable future. Humanity's future may not lie only on Earth, but also in understanding and responsibly using the resources of space.